So hi class, welcome to our first lecture for integral calculus. Okay, so I hope you already finished with your differential calculus because they are quite connected. Okay, so let's have a short recap of your differential calculus. So in your differential calculus, we were given a function of x. Okay, so then upon differentiating the function of x with respect to dx, we were able to get the function of x. Okay? But here in integral calculus, our main focus would be from the differentiated function, we are going back to the original form. And this is what we call integral or integrating. Okay? Or this is also what we call the anti-derivative. Because after differentiating, we already got our derivative, we are going back to its original form or to the form before we integrated it. Okay? So basing it from your module, please be with me, open your modules. Okay? So for example number 1, we have here f of x. F of x is equivalent to 5, x raised to 4. So our main goal is for this function to go back into its original form or differentiated integral form. Okay? So for, let's try to imagine what would be the function that would give me a differentiated value which is 5x raised to the fourth power. Okay? So for example, let's say x raised to the fifth power. Isn't it, if I am going to differentiate x raised to the fifth power with respect to dx, it would be, bring down the exponent, that would be 5, copy x, then you have 5 minus 1, then that is 4. Therefore, f of x, the integrated value or the integral of um, 5x raised to the fourth is x raised to the fifth. Okay, so this is the integrated value. But the question is, or the problem is, this can be x plus 1, or it can be x raised to the fifth plus 2, or it can be x plus x raised to the fifth plus 3, or it can be x plus x raised to the fifth plus 4. Isn't it that the derivative of a constant with respect to dx is equivalent to 0? So it would also be correct if the derivative of x raised to the fifth power plus the derivative of 1 would be 5x raised to the fourth power plus 0. Likewise with this function, you have x raised to the fourth times 5 plus 0. Likewise with this function and with this function. So to make our integral valid, we just simply add a constant c. Okay? So it would be x raised to the fifth power plus c, where c is any value or any constant. Okay? Any constant. Okay? So let's try example number 2. Evaluate the following indefinite integral. So we have we have 5x raised to the fourth dx. No, it's just the same lang pala. Okay? So let's proceed with example number 3. We have a cosine x dx. Cosine x dx. Okay? So the integral of cosine x dx. Now, from our differentiation in differential calculus, what function will give us cosine of x? Okay? So the derivative of sine function of x with respect to dx is equivalent to cosine x. Do you agree? So the integral of cosine x dx is equivalent to sine x. And that is the integral of cosine x. Okay? So letter B, we have the integral of e raised to 2x dx. Okay? So imagine what would give, from differentiation, what value would give us this function. Okay? Let's try to analyze e raised to 2x. If I'm going to differentiate d raised to the e raised to 2x with respect to dx, what would be the function? Bring down 2. Copy e raised to 2x. But that is not our function. Our function is simply e raised to 2x. Then I am going to introduce 1/2. Okay? So the derivative of e raised to 2x with respect to dx, 1/2. Okay? That would be 2 e raised to 2x over 2. 2 will simply cancel out. Therefore, the integral of e raised to 2x dx is equivalent to 1/2 e raised to 2x. Okay? Number 3, a letter C. So we have 2x cubed dx. The integral of 2x cubed dx. By the way, this is the integral sign or integrating sign. Okay? So 2x cubed dx. So what function from differentiation would give us this function? Okay? So going back solving it backwards, the derivative of x to the fourth with respect to dx. So that would be x raised to the third power, bring down 4. But take note, we have a constant of 2. But here our constant is 4. Therefore, I am going to introduce here 1/2. So I am going to multiply here 1/2. So cancel, cancel, and we will be given with 2 as our constant. Therefore, the integral of 2x cubed dx is x to the fourth power over 2. Okay? Next. Now, we have the following. So letter A, cosine x, okay, so that's it, no? So what are the properties of indefinite integral? So we have here the integral of properties. Okay. So the integral of u du is the function of u. Okay? So where u is a function and du is a function of du. U is a function of du, and c is any constant. Okay? Number 2, we have here the integral of k fx is equivalent to, take note that we have here a constant k. So if that would be the case, we are just simply going to factor out the constant. So k times the integral of f of x. Okay, so that would be k times f of x. Okay, so for example, we have here the integral of 3 times x plus 7 raised to the 5th power. So this is simply equal to, factor out 3 times the integral of x plus 7 raised to the 5th quantity raised to the 5th power. Then from there, you're going to proceed with your integration. Okay? Next, you have here number 3. Here, the integral of a sum or difference is a function, is the sum or the difference of the individual integrals. Okay? So this is a binomial expansion. So with that, we have the integral of 3 times x plus 7 squared dx. I forgot to write the dx here. We have here dx. Okay, with respect to x. So we have here. So we're going to factor out 3 times the integral of x plus 7 quantity squared dx. So we need to simplify this term first. So we have 3 times the integral of x squared plus 14x plus 49 dx. Okay? Then we distribute. So we will be having 3 times the integral of x squared plus 3 times the 3 times 14, factor out 14 because that is constant, times the integral of x plus 3 times 49 times the integral of, that's it. The integral of 49. Yeah. No. Kulang pala. Okay? X squared dx plus 3 times 14 times the integral of x dx plus 3 times 49 times the integral of dx. Okay? So this would be if we're going to solve it backwards, what function would give me x squared? So the derivative of x cubed over dx. So we have 3x squared. So I need to cancel out 3 because I do not have a constant here. Okay? So simply introduce 1/3. Okay? So it is 3 times x squared, x cubed over 3 plus, next, x. So the derivative of x squared with respect to dx, that would be 2x. But I do not have a 2 here. Okay? So I'm going to introduce 2. So that would be 3 times 14 times x squared over 2 plus 3 times 49 times the derivative of x, and that is simply x. Then simplify your equation. Okay? And number 4, no, don't forget to write your constant c. Okay? Constant c. So, if integrating the original problem entails some difficulty, then substitution is suggested so a change of variable of integration is introduced. Okay? So don't worry, we're going to discuss that further for the remaining topics. So for the other topics, we're just going to upload the video. It's up to you when are you free to watch the video in your convenient time, so you can adapt to our new normal. And this is our methodology of learning right now. Okay, so if there's any question, just comment down on the comment section where I'm going to post this video.